This recording is about special right triangles. There are two special right triangles. The reason they're special is because they have ratios that are always the same for these angles of triangles. 30, 60, 90 have a special ratio, and 45, 45 have a special ratio. Alright, let's move on. So we're going to talk about the 30, 60, 90 first. So you need to remember this about triangles. Across from the shortest side is the smallest angle, or across from the smallest angle is the smallest side. So if you put square root of 3 in a calculator, you get 1.7. So this is the order of the sides. 1 is smallest, 1.7, approximately 1.7 is next, and 2 is the largest. These numbers come from Pythagorean theorem. You could solve them. 1 squared plus square root of 3 squared equals 2 squared. And you'd get 1 plus 3 equals 4. Alright, across from the middle side, 60, across from 60 is square root of 3. Across from the big angle, 90, is 2, the largest side. This is the other special triangle. This is an isosceles 45, 45, 90 triangle. So these are equal in length, and this has the ratio of square root 2. The hypotenuse does. Okay. Also, with the across from the smallest angles of the smallest side, square root of 2 is like bigger than 1. Alright. So, these also come from Pythagorean. 1 squared plus 1 squared equals square root of 2 squared. 1 squared is 1. 1 squared is 1. Square root of 2 squared is just 2. So this is a true statement. Okay, here is how you use it. So they could give you a special right triangle like this. They could give you just this side, and they could say this is 4. So because you know those ratios always work in this triangle, you can say, oh, well, this one is 2 times bigger, so it's 8. And this middle side, you multiply by square root of 3. Let's do it again. They could give you the long side and say, this is 12. So you can go backward and get the shortest side, which is always half of that. So this would be 6. And then you can go get the middle side. 6 times square root of 3. And you can just leave it just like that. So this is how you get a really easy way to get the side lengths. Let's try it for the 45, 45. Alright, so you got this. Let's pretend this is 5. Well, these are always equal, so this would be 5. And then this one, this hypotenuse would be 5 times square root of 2. So this is a little trickier if they give you the hypotenuse. So let's say they give you the hypotenuse, and it's 6 in length. So to go backwards, you have to divide by square root of 2. So 6 divided by square root of 2. And you wouldn't really leave it like that. This would also be 6 divided by square root of 2. You always rationalize the denominator. So you'd get 6 square root of 2 over 2, which is 3 square root of 2. So 3 square root of 2 is really the length for both of these guys. Alright, let's mix it up. What if they give you this? What if they give you this side and they say the 60-degree side is 5? To go backward, I would always find the short side. So I know I have to divide by square root of 3. 5 divided by square root of 3. And then to get the long side, you always multiply by 2. So if I times this by 2, I get 10 over square root of 3. Now better math would tell you to rationalize the denominator. So you times by square root of 3. And you really get 5 root 3 over 3. And you get 10 square root of 3 over 3. Just over plane 3.